Hi, this instructional video is a continuation of simplifying rational expressions. This time, we're going to talk about multiplying and dividing. Multiplying and dividing rational expressions. Let's look at numbers 1 and 2 and 3. I'll do the first one and you think about doing numbers 2 and 3, okay? So number 1, when we're multiplying in the past, when we talk about division, quotients, we just multiply across. But at the same time, we could think about simplifying whatever we can. So for example, 5 minus 2x over 2. Nothing can be really done with that. Oh, but look! The negative 2 can simplify 24, can it? 12 times, that is. Knowing that it's going to be a negative, okay? Now, 10 minus 4x. Don't those two terms have something in common? Can they not be divided by a common factor of 2? And if I do factor it out, wouldn't this become a 5 minus 2x? Yeah, 2 times 5 is 10. 2 times negative 2x is negative 4x, isn't it? And whatever came out, the coefficient 2, can this not simplify the remaining 12 up there 6 times? Holy moly, look at this. Look what I have remaining when I factor out the 2. I end up with 5 minus 2x. And look at the numerator of this guy. 5 minus 2x. Since the entire binomial is identical, I could simplify that as well. In a sense, they cancel out. So what remains after all that? The negative, don't forget that, is still a negative. When you multiply or divide, if you have a negative, it will still be a negative. And what remains after everything being simplified? We have a 6. Ta-da! Yeah, that's the way I like it. Uh-huh. Number 2. Why don't you try numbers 2 and 3? Alright, so the way this is made, something's gonna simplify. You're thinking something's gonna cancel somewhere. So yeah, you're thinking the right way. So for example, 4x, anything, I'm sure something will come out. But look at this one. We learned this in the past. This is a special product property. It's a difference of two binomials. And you know, if you factor them, they'll be the multiples of x plus 3 and x minus 3. That's what this is. And uh-oh, look at this. Diagonally, look what's up here. X minus 3. So that binomial can cancel out or reduce, simplify this binomial. Now how about this one? Between these two terms, what do they all share? The greatest common factor between 8 and 12 is 4, I guess, huh? And x squared and x, they both have at least an x, so I could factor those out. What remains then? 4x times what will bring me back to 8x squared? It is 2x. And 4x times what will bring me back to 12x? That will simply be 3. Nothing. But look at the 4x. And look at that 4x. Since those coefficients are exactly the same, they cancel out as well. So what remains then? Upstairs everything's gone. Except for the identity, the invisible factor 1. And the bottom, we had the binomial x plus 3 remaining. And the 2x plus 3 on the bottom. And I wouldn't multiply those two binomials. I would leave it as a factor form because that is a simpler form. And there's my answer. And finally, number 3. Too easy. Look at that. X minus 4, x minus 4. Bye-bye. And look at that 3. Can that not reduce the 12 4 times? Just don't forget the negative, okay? When you multiply or divide, you have to keep the negative sign. So since everything's gone except for the invisible factor 1, on the bottom, all you have remaining is 4 times the binomial x minus 7. You didn't get to see any action. But oh well. Now when we divide rational expressions, just like in back in 4th grade, remember? When your teacher says something like, well, here's 2/3 divided by, I'm not making fun of the teacher now, 2/3 divided by 4/9. Remember, what you have to do is change that into quotient, division into a multiplication. but you have to make the reciprocal of the second quotient, or I mean the fraction. Yeah, remember doing something like that back in 4th grade? And then you end up simplifying, simplifying, so you get 3 over 2. Remember something like that? That's what we're going to do here. So, here we have 2 times the quantity of x plus 2. Since we're going to simplify everything, let's leave it like that. Do not multiply. And the bottom, 5 times x minus 3. Now let's make that into multiplication, the product, and then take the reciprocal of this quotient. So we get 4 goes downstairs, and at the same time, let's go and factor out the 5 between the 2 common terms here. So we get x minus 3. And look at that. Is that cool or what? X minus 3, x minus 3. Be gone. 5 and 5. You too. Not the x minus 2 and x plus 2. However, the 2 can reduce the 4 2 times. So at the end, what remains on top is the x plus 2. What remains on the bottom? The 2 times the quantity of x minus 2. And there we have it. Okay, number 5, since I took up the space over here, let's bring it down this way. And let's factor this trinomial on the bottom. Okay, we're seasoned veterans now, we could do that. So we get 3x, and the bottom, what times what is x squared? I would say x and x. What times what is a 24? I will say, well, there's many multiples, so I'm going to say 4 and 6. You know why? Because look at the next quotient. I see a x minus 6. There's got to be something, some sort of a hint about that. Anyway, to finish this up, so what would I do with the 4 and a 6? Their sign should be so that if I add them becomes negative 2. Well, the bigger negative number has to be a negative and the smaller one positive. Now let's change that division into multiplication and take the reciprocal of this guy. So x minus 6 now goes on the top. Nice. And what's the common factor between 6x squared plus 9x? It is 3x. So what will remain if I factor out the 3x from this binomial? That'll be 2x plus 3. And let's clean up the house. X minus 6, x minus 6. The 3x right here, 3x right there. That's it. What remains on the top? Just the invisible factor 1. How about the bottom? We get x plus 4 times another binomial, 2x plus 3. There it is. And finally, number 6. Okay, number 6. We have a little potpourri of things going on here. We have a multiplication inside of parentheses. And you know what? There's nothing to cancel diagonally or up and down, so let's keep that together. X squared times x plus 2. Yeah, I could do that. And 5 times 2 is 10. And let's make that multiply. At the same time, make the reciprocal of x over 30, which is now 30 over x. I thought this was going to be a spicy one. It's kind of bland now. The 10 reduces to 30 3 times. The x reduces the x squared x times. Everything's gone. So what do I have remaining on top? It's just 3x times the binomial x plus 2 over 1. But that's kind of redundant. So that's going to be my final answer. Have a good day. Have a good day. Have a good day.